All right, here are your solutions to your first homework question from 2017. See if I can clear that up. So I want you to do your work on a separate piece of paper, but I'm going to show you also. Here's the first question that's in your packet, and I'm going to try to annotate this to the best of my ability while I'm doing this. All right. So this is a graph question, and in calculus, when you graph, you're going to be asked to find the slope at a point for derivative, or area. And area above is positive, area below is negative. So here's a function. First thing I notice is that this is a derivative graph. So that's f prime. Now it says the function is differentiable from -6 to 5. So at every value from -6 to 5, you can find the derivative off this graph. And it gives you a starting point. So when the function is -2, the answer is 7. You're given the graph of the derivative, and it's a semicircle and 3 line segments. And then we get started. So first, find the values of f at -6 and f at 5. How do I do that with calculus? So they give you a starting value for the function, which is 7. And then the x value is -2. So let's look at that. Let's see if I can get back into here. All right. So in the question, it gives you this starting value. And it says, hey, can you find f at -6? And then what would the setup look like in calculus to find that value? A really common question in calculus. So we're going to start with the y coordinate, which is 7. And then we're going to add and integrate the derivative. And we're going to integrate starting with the x value for what I'm given to whatever x value I'm looking for. And again, I'm going to integrate the derivative. The first thing I look for to integrate this derivative is this proper or improper. So is the bottom number bigger than the top number? So is the lower bound larger? And it is. -2 is larger than -6. So whenever the lower number is a larger number, we start with the negative because it's the same area, but it has to be the opposite number. So the easiest way to do the opposite number is just start with the negative, parentheses, and then go to the graph, and then find the area from -2 to 6. So let's see if I can go back to this graph. So from -2 to 6, here is -2 to 6. So you can see what shape that is. That's a triangle. So what am I looking for in this triangle? Is it above or below the axes? It's above, so we're going to do that positive area. And what's the area of a triangle? So it's half the base times the height. So the base here is 4 and the height is 2. So the triangle is half the base times the height, and that's it. Now we might need to simplify it for later on in a question, but right now we can let that go. The second part is to find the value at 5. Same setup. So what's the value of f at 5? Start with what we're given, which is 7. And then we're going to integrate the derivative. Again, starting at -2, and then going to what I'm looking for, which is 5. Again, I look, is the bottom bound lower than the top bound? It is, so it stays positive. And then I'm going to find the area from -2 to 5. So I'm going to go back to the graph and find the area from -2 to 5. So let me change the color here. Let's go red. So -2 to 5. So -2 to +2, that's a semicircle. So I'm going to find the area of this. Do you notice that the area is below, so it's negative? And then if I continue all the way to 5, I have 3, 4, 5. This area here, which is a triangle, which is positive. So I'm going to find both of them, the area of the semicircle and the triangle. So for a semicircle, it's pi r squared, but divide by 2. For a triangle, again, it's half the base times the height. So for this semicircle, the radius is 2. So I'm going to come back here. So again, it's below, so it's going to be negative, and then pi r squared divided by 2 because it's a semicircle. Then the second one is a triangle. So that's half the base. The base is 1, 2, 3 across, and a height of 2. And I have my answer. I don't need to simplify it for this part. There might be a question later on that requires me to know that answer. So if I need that exact answer or simplified answer, I will when I'm being asked for it later on. So 3A is done. 3B. So on 3B it says, on what intervals is f increasing? Let's go back to this again. So on what intervals is f increasing? Now remember, this graph is the graph, and I'm going to erase this now so I don't have to see it. This graph that I'm looking at is not f. So the worst thing we can do is go, oh, look where it's increasing. So I can see where it's going up to the right. Well, that would be true if it was f, but the derivative it is not. So instead, to know where it's increasing, I'm going to draw a number line. So I want you to draw a number line, and then on that number line, we're going to write down the critical numbers of the derivative. So where is the derivative equal to 0? So in other words, where is the derivative, the x-intercepts of the derivative? Those are the critical numbers. So that's at -2. It's also at +2. And we have our end points, which are, again, -6. There's really not an arrow. That's -6. And that one's at 7. Okay, so from -6 to -2, do you notice the derivative is above the x-axis? So that's a way of saying that the derivative is positive. So what does that mean when the derivative is positive? It means it's increasing from -6 to -2. From -2 to 2, it's below the axis, it's negative. What does that mean? It's decreasing. And then from 2 to 7, again, it's above, so it's positive, so it's increasing. So in what interval is the function increasing? And the answer is from -6 to -2, and from 2 to, that's a 5, isn't it? 5, not 7. So it's from 2 to 5 is the end point there. So we're going to write that down. So we're going to write down what we said. So f is increasing, and the intervals, which we just said was -6 to -2 and 2 to 5. And then we're going to say why. So we're going to say that, and then we're going to say the word because. And then tell me why we said that. And that's because the derivative is positive on those intervals. Done. All right, next one, 3C. In 3C, it says find the absolute minimum value on this closed interval from -6, and then justify your answer. So whenever I see absolute minimum or absolute maximum, that is a table of value question. So we have x and we have f on the other side. We start with the end of the interval. So we do start with -6 and 5. And then we think, what are the critical numbers from -6 to 5? And we just found them, -2 and +2. So those are the 4 values I have to evaluate at. So I'm going to switch over to my hover cam, but we're going to do a table of values, and we're going to find what is f equal, -6, 5, -2, and 2. Okay? So I'll switch over again. So again, here's my table of values. I want to find the absolute minimum. So the ends of it, which we said were -6 and 5, and then the critical numbers, which we found already in part B, which were, when looking at it, which are -2 and 2. So I need to know what f at -6 equals. So if I look above, I already did f at -6. I just didn't simplify it. Now I actually need to simplify it because I'm comparing answers to see which one will be my lowest answer or smallest answer. So 4 times 2 is 8, and half of 8 is 4. So 7 take away 4, so the value at -6 is 3. I also know 5. I just need to simplify it again. So 3 times 2 is 6. Half of 6 is 3. So we have 7 plus 3, which is 10. And then we're going to simplify the semicircle. So 2 squared is 4. Divided by 2, that's -2 pi when you simplify it. So that's 10 subtract 2 pi. At the end, we're going to compare all the answers and then identify the answer that is the least or smallest. So we have not found f at -2. So in order to find these two values, we need to go back to part A. And what's the template that we've been using? So we're given a point. So we start with 7. And then I integrate the derivative. And again, I start with -2, and then the upper bound is what I'm looking for. So in this case, the upper bound is -2. The good news here is if the upper and lower bound are the same number, that means there's no area. That means that's 0. So that answer is just 7. The next one, we're going to have the same template. We're going to start there with 7 and -2. This time we're going to integrate up to 2, the derivative. I look. Is this a proper integral where the bottom number is smaller than the top number? Yes, so it's going to be plus. And then I need to find the area from -2 to 2. That's that semicircle. So the area there is negative. And again, it's pi r squared divided by 2, that semicircle. So if I simplify this, 2 squared divided by 2, that's -2 pi. So I have 7 subtract 2 pi. Now we need to look at all the answers and go, which one of these answers is the smallest answer? So it's definitely not 7. I see 3, and then I see these with pi. So the best is to just use a simple number for pi, like 3 instead of 3.14. So if I go 2 times 3, which is 6, 10 take away 6, the answer is about 4. That's not going to be a smaller answer. Here, if I go 2 times 3, that's 6. So 7 take away 6, the answer is about 1. That answer is 3. So you can see which answer is my absolute minimum of those 4 options. And then we're going to write it down. So the question again says, find the absolute minimum value. So the absolute minimum value is 7 subtract 2 pi on the interval -6 to 5. So the absolute minimum value is 7 subtract 2 pi of that function on this interval, and it's done. And this is the work that justifies your answer up here. All right, last question for question number 3, 3D. Let's see what the question's asking us to do. So let me do this. Find the second derivative at -5 and the second derivative at 3, and then find the value or explain why it doesn't exist. So if you're given a derivative graph, to find the second derivative, you take the derivative of the derivative. So on a graph, if I find the derivative, I'm looking for slope. So at -5, I find where -5 is, and I go up to the graph, and I go, what's the slope of that line is the derivative. So if I follow the endpoints, that is down 2 and to the right 4. Go back here. So I went down 2 and to the right. I don't need to simplify it. Now the second one's at 3, and it says I don't need to explain that answer if it exists. Explain why it doesn't exist is what it says if it doesn't exist. So at 3 is right here. And explain why it exists or doesn't exist when I look at the derivative at 3. So the derivative of 3 is finding the slope. It does not exist. And you can see there's a corner here, right? From the left and from the right are 2 different derivatives. So exactly at 3, from the left, the slope is positive. From the right, the slope is negative. So it does not exist because of that corner. But how am I going to explain that calculus language or mathematically? So let me show you that. And what we're going to do is write a limit. So the limit as x approaches 3 from the left of that derivative and you can either say what the slope is or say it's negative. Actually, that one is positive, isn't it? From the left is positive. It's rising just like this. So from the left it's positive, from the right it's negative. And because from one side it's positive and from the other side it's negative, they don't agree on what the derivative is, so therefore it does not exist. So it has two different derivatives at the same time, one from the left and one from the right. So if I wrote it a little neater, the one from the left is positive, the one from the right is negative, and because they are not the same value, they don't equal each other. And we can also write this step. Does not equal. So the second derivative from the left and from the right, they don't equal each other. One's positive, one's negative, therefore that second derivative doesn't exist. Done. All right, one more question for homework. So this one is from 2016. Again, a graph question. And if you look, in fact, I'm going to write this out. So if you look in your packet, you're given a graph, and then you're told that g is defined using that graph. So g is the integration from 2 to x of f. And you're given a graph that's f. And right away, before I do any other work, I'm going to write down what the derivative is and what the second derivative is, and then I have like a template to go back to. So the derivative is, the derivative integration, they cross out. This happens a lot. To be defined as an integral, then take the derivative, they cross out, and then this just plugs in. So the derivative of g is equal to f at x. So the derivative integration, cross out, you plug in x, there's no hooks, this is 0, it's just f at x. That means the second derivative of g is equal to the first derivative of f. And we're just going to make sure whatever we go back to, we understand it in the context of these equations. All right. In 3a, it says, does g have a relative minimum, maximum, or neither at x equals 10? So when you see the word relative minimum for g, that means you're going to take the derivative of g, make it equal to 0, solve for x, draw a number line, and look at the sign changes. So if I take the derivative of g, that's that, and make it equal to 0. So the graph that I'm looking at the x-intercepts of f. And go, okay, where are the x? And there's lots of x-intercepts. So where are the x-intercepts? So I'm going to get rid of this one. And we're here. All right, so we have an x-intercept at -2, 2, 6, and 10. So the x-intercept. These are the critical numbers of g. So the derivative of g is the same as just f, and those are my x-intercepts. That's what I'm going to put on my number line. And then if it's below, it's negative. If it's above, it's positive. So you can see what the signs are going to look like in terms of it. So it's negative, positive, positive, negative, negative. All right, let's go back here. And again, the numbers, which are -2, positive 6, and positive 10. So again, it's negative, positive, positive, negative, negative from the graph, above and below. So at 10, what do you notice at 10? Is it a maximum, a minimum, or neither? And do you see there's no sign change? And I'm going to write down when x equals 10, g has neither a relative maximum or minimum. Because, and what reason are we saying that there's neither? Is because the signs, right, of the derivative don't change. And that we understand that g is decreasing before and after 10, and therefore there is no relative max, there is no relative min. So there's part A. Part B. In part B it says, does the graph of g have a point of inflection? So we know for a point of inflection, we're looking at the second derivative. So for the second derivative, off the graph, we're looking at the first derivative, and we want to know what the critical numbers are, equal to 0. Where is the derivative of what I'm looking at equal to 0? Or it can be undefined. So in other words, we're looking at the turning points. So we have a turning point here, and then here, and then here, and so on. And it says, does the graph have a turning point at x equals 4? So we're just looking at 4. So let me erase the rest then. So if I only look at 4 right here, can you see it changes from increasing to decreasing? So therefore there is a point of inflection at 4 because the signs change there. So let's write that down. So at x equals 4, the second derivative changes from positive to negative. That's the increase and decrease, and therefore creates a point of inflection. All right, 2 more left. Find the absolute minimum. That's part C. So what do I draw first for absolute minimum? Is a table of values. And we have to find the absolute minimum and absolute maximum of g. And from the interval -4 to 12. So we start there from -4 to 12. And then we look at our critical numbers. So the derivative of g, again, is equal to f at x. And we're looking at where the critical numbers have sign changes. We don't have to look at every single one. So we have a critical number here at -2, and the signs change. That needs to be on my table of values. And we have one at 6, the signs change. So at 2, it stays positive. At 10, it stays negative. So 2 and 6 are the ones at -2 and 6 I need to add, and then find the value of g for each one of those. So I'm going to go back to understanding g again is integrating from 2 to x. So the graph is f. So all I need to do is plug in and find the different values. So I just got to do one at a time. So g at -4 means integrate from 2 to -4 the function that you see. Find the area from 2 to -4. The bottom number is bigger. So we're going to start with the negative. And then we're going to find the area from 2 to -4. So what shape is it from 2 to -4? So from 2 to -4, so I see a triangle here. That's a negative triangle, half the base times the height. So 1/2 of times 2. And notice it's below, so we're going to say the height is -4. It creates that negative area. Plus the triangle that's above here. So half the base here, that's 4. And then the height is 4. And then I'm going to have to simplify it because I'm comparing answers to know which is my minimum and which is my maximum value. So if I simplify this, -8, I have my negative in front. So half of -8, half of 16, that's +4, and then the negative in front makes it -4. So we have a value. Now we have to do that for each one. So g at 12. So start with the equation. I'm integrating from 2 to 12. So the bottom bound is smaller, so I just find it's a positive value, and I just find the areas from 2 to 12. So let's look off the graph again. Let me erase what I have here. So from 2 to 12, and how can I make it easier? So notice this triangle here and this triangle here, one above and one below, they are exactly the same size, but one's positive and one's negative. So I don't really care what the number is, because whatever the answer is, that's 0. And then all I have to do is find the area here of this triangle down here, because that crosses out to be 0. So half the base times the height. So half of 2 times -4. And that's it. And then simplify it. So that answer is also -4. We have 2 more to do. So g at -2. This one's going to be again, it's improper because the bottom number is bigger. So we start with a negative. And then what's the area from -2 to +2? So go back to the graph. Let me erase this. So from -2 to +2, that's just this triangle right here. It's above the axes, it's positive. Half the base times the height, so half of 4 times 4, so that area is 8. So again, half of 4 times 4, so that's 8, but it's negative in front because it's improper. And then one more for 6. So we're going to find the area from 2 to 6. Notice the bottom bound is smaller, so it's just a positive value. I don't need a negative in front. What's the area from 2 to 6? So from 2 to 6 is that same triangle I just did, right? But this time it's a positive value because the bottom bound is smaller. So that number is just 8 for that triangle. Then look and tell me what's the maximum value and what's the minimum value. So our minimum value, absolute minimum value, is -8. The absolute maximum area or maximum value is +8. And the work that we showed in the table of values is what justifies your answer. All right, last question, D. In D it says, from -4 to 12, find all intervals in which g is less than 0. Again, if I understand this in terms of g, which of the numbers give a negative answer in terms of it? So anything to the left of 2 is going to be the opposite number from what I see. So let's look at this. To the left of 2. So let's erase this. So if I go to the left of 2, I have this triangle, but it's the opposite because it's to the left. So this triangle's area, whatever that positive number is really a negative area, and it's bigger than this. So any number I pick between -4 and 2 will give me a negative answer because of the area of the triangle. So again, it's the opposite number. So the area here is, this area was 16, but because the bottom number is smaller, it's going to be negative. And this one is going to be +8, but because if I integrate with any number between -4 and 2 and I add it up, the answer is going to be a negative answer. So even from -4 to 2, I'm still going -16 plus 8, and the answer is -8. If I pick any number between -4 and 2, the answer is going to be negative. Now, what would happen if I pick a number after 2 where this number is proper? So we have a positive area from here to here. If I go all the way to 10, the answer is 0. And if I go all the way to 12, after we cross these out, I actually do get a negative answer. So if I integrate anything past 10 to 12, I get a negative answer. And anything from -4 to 2, I get a negative answer. So the answer is from -4 to 2 and from 10 to 12. It doesn't tell me to justify my answer or give a reason, so I'm looking for that. So they're just looking for the answer to be correct here. So the correct answer is, if you integrate any number from -4 to 2, it will give you a negative answer. And any number from 10 to 12, it would also do the same. We actually would have to block this out and block this out. Perfect, because at 2 it's equal and at 10 it's equal. But those are the intervals. Excellent. Mr. G Math, over and out. We're going to go over this again in class when I see you.